Hello class, this is section 1.1, which is titled Sampling. I am your instructor, William Buellman, and this is Stat 1200. So what are the objectives for this section? So the objectives are for you to be able to construct a simple random sample, determine when samples of convenience are acceptable, describe stratified sampling, cluster sampling, systematic sampling, and voluntary response sampling, and to be able to distinguish between statistics and parameters. So we need to start off with some definitions so you can speak the language. So first, statistics is the study of procedures for collecting, describing, and drawing conclusions from information. Next, we have a population, which is the entire collection of individuals which the information is sought. So the population is everybody that we're trying to take information about. Next, we have a sample. A sample is a subset of the population containing the individuals that are actually observed. So our sample isn't the whole population. It's only part of the population, because if we had the whole population, there wouldn't be a question. We would know the mean age. We wouldn't have to say we think it's about a certain age. So now we have different methods of sampling which are correct for different types. So the preferred is a simple random sample. So in a simple random sample, we take size n, however many we want, is conducted in which each person in the population has an equal chance of being chosen. So if we have 100 people, all 100 people have the exact same chance of being chosen. Next, we have a sample of convenience. So this is where it's not drawn from a well-defined random method. This is okay occasionally because there are times where a random sample isn't possible, and we will see that. So sometimes a convenience sample would be appropriate. In stratified random sampling, the population is divided into groups called strata, and then we take a simple random sample from each of those stratums. So first, we divide our population into groups. So here, let me draw you a little basic picture of that. Okay, so we're going to draw some groups for stratified random sample. So first, what we do is we take our samples and we break them up into, let's say, 3 stratas. So we took 15 people and we broke them up into 3 groups. Group 1, Group 2, and Group 3. Now from each one of these groups, we take a simple random sample. So that's a stratified sample. So we break each one into a strata, and then maybe I take one from this group, one from that group, and one from that group. So that is a stratified random sample. And next we'll see something very similar to that. So we have cluster sampling. Items are drawn from a population and n groups are clusters. So in cluster sampling, let's say we have the same 15 people. So here they are. But the difference is this time, instead of picking randomly within the stratas, we're going to pick a whole strata at random and use everybody. So we will use all 5 people instead of randomly picking one from a group. So we randomly pick the group instead of one from each group. Next, we have systematic sampling. In a systematic sample, we order the items and we pick every kth item. So for that, we may go, okay, I'm going to start at the 3rd person in line, and then I'm going to ask 4 people after that. A voluntary response sample is one made up of volunteers. So these is where people can opt into your study. People are putting themselves in your study, and that creates a problem because they have chosen to participate in your study. You haven't chosen them to participate in your study. So we'll see that voluntary response sampling is not very good. Next, we have a statistics. So statistics describes samples. So whenever we're talking about statistics, we're talking about the sample. And then we have parameters. Parameters describe populations. So a good rule of thumb is to remember is statistic starts with S, sample starts with S, parameter starts with P, population starts with P. So just remember that statistics go with samples, parameters go with populations. So now here's an example of a simple random sample. So we're going to suppose there's 4,000 freshmen at Cal Poly Pomona. I want to take a sample of 100 freshmen and see how they felt about the dining services on campus. So to do this, I would create a list of all 4,000 freshmen and give them a number from 1 to 4,000. And then I could generate a random number, let's say 393. Okay, whatever student is in line 393, I'm going to ask them what they think. And I do this 100 times until I have 100 different students that have all been chosen randomly. So since all 4,000 students had a 1 in 4,000 chance of being picked randomly from the sample, it is a simple random sample. They all had an equal chance of being picked. Next, we have a convenience sample. So suppose we have 5,000 bricks that we want to know the crushing strength of. We want to sample 15 bricks from the pile to get an idea of the crush strength. Well, if we were to take a simple random sample of these bricks, we would need a few from the top, a few from the middle, and a few from the bottom. Well, how do we get the bricks from the middle and the bottom of the pile? That's not really practical or even doable. So in this case, we have to go to a sample of convenience and go, okay, well, all the bricks should be the same. They were all manufactured the same. They were all from the same lot. So we can treat them as all being the same. So since we have no reason to believe that they're any different, we'll just take 15 from the top of the pile and treat it as if we did a simple random sample. Again, you don't want to do this unless you have to, but if you have to, long as you can justify that all of them would be the same, it is okay. So now we have stratified random sample. So suppose we walk into a classroom with 24 students and we want to sample the ages of 6 students. So suppose that we notice that there are 20 females and only 4 males in the classroom. How can we divide this into a stratified random sample? Okay, so first what we're going to do is we're going to have to split them. So let's split them right here. Here's our 4 males, and here's our 20 females. So again, these are our males, and these are our females. So now we've split them into 2 different stratas. So since the females are approximately 83% of my classroom, I want to make sure about 83% of my sample is female. I want to keep that same ratio from my sample, my population. So what I would do here is I'd pick 5 females at random. So maybe this female gets picked, this female, this female, this female, and that female. So now I've chosen 5 females at random. Similarly, I need to pick one of the males. So maybe this male over here gets picked. So now I've picked 6 people from my classroom, and I've made sure that they stayed in the same percentages as if they were from the population. So this is a stratified random sample. And you can see how I took 1 out of each strata. Or I took, in this case, 5 females and 1 male. So each strata has been represented. So next we have a cluster sample. So suppose Apple wants to come out with a new iPhone that's targeted towards college students, but Apple doesn't want to spend the money in having to, go to every college and sample all the students. That would be impractical, it'd be very difficult. So what Apple's going to do is they're going to pick 10 colleges at random and then do their samples from there. So what happens here is, we'll have a college here, college here, college here, college here, college here, college here, college. So we have all these different colleges. Right, so here's whatever they are, all the ones in the United States. So what's going to happen is Apple's going to randomly pick these colleges whatever they are. Maybe one of them's Cal Poly, another one is University of Florida, maybe there's one in Hawaii. So we have a bunch of different colleges. They picked 10 of them. So now from each one of those 10, they're going to sample students in that college and get what they want. So you can see this is different from strata, because in stratified random sampling, each strata was represented. In this cluster, each cluster is not represented. So next we have the systematic sample. So as I said earlier, suppose we ask the fourth person entering class and every third person thereafter what they had for breakfast. This is a systematic sample because I've come up with a system of how I'm going to ask people. So the first person comes in, I don't ask them. Second person comes in, I don't ask them. Third person comes in, I don't ask them. When the fourth person walks into class, I go, hey, what did you have for breakfast? They tell me, I write it down. Fifth person comes in, I don't ask them. Sixth person comes in, I don't ask them. Seventh person comes in, I go, hey, what did you have for breakfast? And I write it down. So if we had 30 students in the class, I would have to ask the fourth student to enter, the 7th, the 10th, the 13th, the 16th, the 19th, the 22nd, the 25th, and the 28th student who entered the class what they had for breakfast. And finally, we have a voluntary response. So this is if I just create a poll on Facebook, Instagram, some social media, asking who they would vote for in the presidential election. So this is voluntary because people get to choose whether they respond or not. And people who do respond are more likely to have strong feelings. So that's a problem that we have with voluntary response, is the people who are kind of lukewarm, who don't really care, probably won't respond to your survey. But the people who are really passionate on one side or the other, like one candidate over the other a lot, are more likely to respond, and that can create some bias and some skew in your data. So hopefully at the end of this, you kind of now have an idea of the 6 sampling methods that we use. You now understand what we need to construct a simple random sample. You now know when we can use a sample of convenience. You can describe the difference between a stratified sample, a cluster sample, a systematic sample, and our voluntary response. What are statistics and what are parameters?